We're good. Hi, good morning, everyone. Welcome back to our 2-Bit Circus Foundation Playful Learning live stream. My name is Evelyn, and today's project has been derived from the CMAP playbook. This is called Density Pillar. So, what we're doing here today is just making like a stackable layer of different kinds of liquids that have different substances and liquids that have different properties, so we can just like visually see how different liquids are able to like stack depending on like the mass that they have. Um, and just to go over the materials here, we have, of course, a container to put your liquids in. For example, I have these, a glass cup, or even like a long. This is actually like a candle, so I use a candle, and it was reusable for this project as well. So you can like just stack different layers. Also, you'll need ping pong balls. You'll need soap. I have here my dish soap. I have oil. A vegetable oil would be the best to use. I also have milk, and I have food coloring, and also you need water. Tap water works just as fine. But before we get started, I want to show or tell you about a riddle or a trick question. So if you have a pound of feathers and a pound of bricks, which one do you think would be heavier? Are you guys okay? So just to give you the answer, it's actually neither. They both weigh the same. However, there is a difference though. The feathers will take up more space than the 1 pound of bricks, because to get 1 pound of bricks, 1 pound of feathers, sorry, you'll need a whole bunch, and that takes up so much space. Rather than just 1 pound of bricks, you will just need like 2 bricks, 3 bricks at probably less. But yeah, that's just like an intro to density. So density is the measure of mass and the structure of a substance. So again, thank you guys for tuning in. Happy Wednesday. I hope you guys are enjoying your midweek day today. Thank you for joining me again this morning. The project we'll be doing today is density pillar for those who are just tuning in this morning. The materials, we will go over the materials when we hit that project, but first I want to give you guys a few examples of density regarding eggs and salt water, and a few other projects that I will just show you. However, first let me just start with a simple introduction, or a simple project first. Let me just move this to the side. We're gonna grab 2 containers here. I have 2 eggs here, and this experiment is just seeing the differences between salt water and using tap water to see which one would float. So just to hypothesize, and before we observe our experiment, would you guys comment below, like, what do you guys think? Do you think the egg will float using tap water, or do you think the egg will float using salt water? Like, what are your hypotheses? Can we use something that's besides? Yes, you can actually use something besides eggs. Anything that weighs like less than 1 gram, I would say. You don't want it to be like very dense in the water, because water is like about like 1 gram. It weighs about 1 gram. But yeah, an egg. You can even use ice, because as you also know, ice floats when it's like inside a beverage, because the way the molecules are arranged inside the ice are very loose. So that means it has a very little mass, which doesn't, allow it to float, or sink down below. So yeah, I've also used, besides eggs, I know you can use potatoes if you just peel them, like really tiny potatoes. I have an example here as well. Let me just take this out. You can use eggs. And the reason why, actually I'll elaborate into that later, but the reason why the egg tends to float is because of the mass, actually, and the volume. So if you guys remember back in chemistry or physical science, the way density is calculated is mass over volume. So if we take, for example, if we had a scale, and I were to weigh my 2 containers, probably less than like a 0.1 gram or something. and then subtract it by the way that I add to my water, we would get like the density of how it is. Good morning. It is good to see you. Floaty eggs. Yeah. But like again, to answer the question is you can use anything besides eggs. I also have ping pong balls. You can use that. Eggs. I know you can use an orange too as well. I saw a video where you have two different types of oranges. One that is peeled and the other one that is not peeled. So the one that is peeled tends to sink to the bottom, and the one that is just like an ordinary orange, not peeled, tends to float to the top. So let's just start by grabbing two containers, grabbing some water, and filling it up to like this. Make sure they're both about the same. Now I am going to stir in some like table salt. Any salt would work fine, and you just want to add a lot to one container. So there I go. I'm adding a lot of salt, and then I'm going to grab a stick and stir it up. A spoon and just stir it up, and you can tell the difference as well, which one is water and which one is not. Because water, as you can tell, it's very clear and transparent. However, the salt water is cloudy, as you can tell. So I'm just stirring it up. And there we go. Another popular experiment is sodas. So if you know, soda is just like sugar and carbonated water just used together, and I'm pretty sure you've seen this example too. It's very, very popular, where it's you have like, you know, a bucket or a container filled with water, and then you put in like a Coke inside, and then a Diet Coke, and you see how the differences of how they each can like float or sink, whether. And the reason why that is too as well is because of the structure of the molecule. However, they are the same type of weight in the same can. That doesn't really matter. What matters was what's like inside. So the way the molecules are structured, meaning the regular Coke has more sugar than the Diet Coke. So if you can like look up a really an image of the molecules of Coke and then Diet Coke, you'll see all the like this the molecules and the bonds and the sugars, how they're like tightly compact, rather than the Diet Coke, which is, you know, not that compact. But let me just keep stirring. I think that's good. So now here is my first test. I'm gently going to, you know, just put it down there, and you see how it is sinking, right? Sinking. Okay. Next we're gonna do is add the second egg to our salt water. And just stir it just quite a bit. So let's say if I have like one, to do this at home, this experiment at home, let's say I have 1 cup of water, you'll need about 3 tablespoons of salt for this experiment. Or you can just, honestly, just eyeball it. Add as much salt as you can. So here we go. And now let's see if I drop it in, and it's floating. So if I tug it down just to break the surface tension, it is, you know, coming right back up. You can see the difference here. I can see the shell of the egg just popping out compared to the one with tap water, which is just sinking down below. But yeah. And like I said, you can try this with pretty much anything at home. Of course, like, be very cautious of the mask, because if you do have like, let's say, a brick of wood rather than like a nail, which ones tends to float and which one does not, you know? So let's take those, like the weight into consideration too. Good morning. Okay, so here we have concluded that, you know, using tap water causes our egg to sink, and using salt water causes the egg to come back. So this is something called the buoyant force as well too. All right, so we're done with this example, you know, just to visually see how an egg, both the same size, both have similar weight measures, tend to have different properties when put into salt and tap water. So moving on to our next one, just putting this to the side, and let me just remove my eggs, or I should just leave it there. Okay, and let's see, let's maybe try it with a potato now. I'll bring this back actually. So I have my regular water and my salt water here. So I'm going to just remove this egg and then put it inside. Alright, so now I have this potato. You see how it's sinking to the bottom? How about if we add it to the one with salt water? Will it float? It's staying. Pretty floating. But yeah, let me see if I can just roll it a little bit. Okay. Maybe if I peel these, you know, they will talk more. Okay. So this one is done. We're gonna put this to the side, and we're gonna do another experiment. I'm gonna just put these inside here. This one. So here I have some oil. So I have some vegetable oil, and I have droplets of food coloring. So I'm going to use a glass container here. I'm going to fill it up with water. Let me just use this water. Just here. Like that. Probably a little less. So here. And then we have oil, but I don't want to use all of it. Maybe I will. So if you have food coloring, you can just add a few droplets of any color you like. Okay. So we're gonna add tiny bits of water. You can see how cool like the little bubbles form. Alright, that's enough of blue. Let's go crazy with these food coloring. Alright, so we're gonna add red now. You can see how slowly these droplets are dropping down to the bottom. You can see the little bubbles here too. I'm not sure if you can see up high, but yeah. Alright, let's put this here. Put this here. Now we're gonna add a little drop of a green. Like that. And so what I'm doing here is I'm going to mix the vegetable oil with the food coloring and add it to my water here on the side. And there we go. So now that we have different colors in our oil, we're gonna stir it up. I'm gonna stir it up really quickly. Or maybe not. Maybe let me use this end here. So you should see it's gonna turn into like a very dark color. So you want to spin it very fast. What does it say? Agreed. Okay, I know you're having some difficulty hearing me. I will speak louder. Let me just bring the mic close to me. Okay. Okay, now that we have this here, you can see little bubbles here. Just make sure. So I have here in this container is vegetable oil, and I just added a few droplets of food coloring to my solution here that is just water. I should have brought some paper towels, but that's fine. Because this can get pretty messy. As you can tell, I have oil on my hands because I switched it, but let me just go ahead and add this. Alright, remember, just stir it as fast as you can because you want it to get you want it to turn this color, which is very dark. Alright, and then here comes the cool part. What we're gonna do is, let me just stir it a little bit more. Alright, excuse me for 1 second. Thank you so much for these paper towels. Alright, so first let me just clean this up here, because we don't want oil on here. Okay. So now that I have mixed it all together, let me see. So we're stirring and stir and stir and stir. Right. So keep stirring until we have this consistency, and now we're gonna go ahead and add it to our thing, and you can see how the oil stayed to the top, and how it's slowly, the oil, you can see here how it's slowly just rising up to the top, as you can tell. And I know it's really hard to see because the camera is a bit far away, but yeah, you can see the oil just went to the top. And in a few minutes, you should see all the food coloring that I added just, just come down and disseminate in the water. So I'm not sure if you can get a top view of it. It should be like that, and then all around is the food coloring, like that. So this is just to show off the different density that oil has compared to water. You see water is denser than the oil. So you can try this at home as well. All you would require is just simply water, oil, food coloring of any color of your choice. Just rapidly stir it in, and you get this awesome like mosaic art of little droplets of water, of food coloring, sorry. But yeah, this is pretty much it. And it's just like a very cool experiment just to try out. You can get like a fun science art project out of this if you try it out at home with the kids. And you can see how it's just slowly starting to go away. Let's see what happens if I stir it. What would happen if I stir everything all around? Oh, it's gonna turn black. Do you guys think it'll turn black, or do you think the oil and the water have mixed up? So let's just wait and see what happens. Since it's very dark to see, I know for sure it's just gonna stay dark because we have fused in all the colors. However, the oil will begin to rise up very slowly, and I know it's very hard to tell because you can't tell anything on here, but the oil will stack up above, and then the water will fall underneath it. But yeah, this is very cool. You can kind of see if I put it up to the light, you can see the oil shining through, and then the water is the rest. But now since I stirred it all in together, yeah, that happened. So, all right, we are going to just clean up this mess here because we kind of spilled some oil all over it. Here, and let me put this to the side with this. This is, no, I'll not put it there. Let me just put it here to the side. Remember, oil can can stain clothes, so I would, prefer that kids wear gloves. So rubber gloves, easily just snap them on because they will tend to touch everything, and it's very hard to remove oil from clothes, even if you wash it with detergent. There are some soil removers you can, use that as well, but just to prevent any stain oils on clothes, because I have had that happen before to me, and I kind of ruined my favorite shirt by because I was cooking with oil, and the oil happened to jump on me when I was let's say cooking, and it stained my favorite shirt, and I was pretty bummed out. But yeah. Oh, okay, that's fine. Now we're gonna go ahead and try something else. I'm going to grab a container just to make sure that none of the water that I am putting inside here will just come out of the bowl. So again, I'm going to use some water here and pour it. That's about a good amount. And then let me just read your questions. I would never guess the water. Thinner than oil, denser than oil. Yeah, actually water is denser than oil. So I had the ice cube example. The molecules inside the ice cube are very, very loose, meaning, it doesn't weigh as much as the water does. So that's why ice cubes, tend to float. However, rather when they're what you call it? Melting, sorry. When they're melting, you can, also the same thing, they tend to float as well. But, okay, so now this is another experiment. It is just like the one we just did here, except we're adding another just fun component, which is an aspirin. I'm pretty sure you've done this at home as well. If not, please feel free to try it out. It's really, really cool. And all these materials here that you have are household materials that you can easily find accessible. Of course, there is always room for experiments and trying out things. So if you want to substitute, let's say the water for something else, totally go for it. And you can make your own, just deduct your own conclusion and say what worked, what didn't work, because that's the process. That's the process of science and the process that we learned of using the scientific method. So first, you ask something, a hypothesis. Next thing, you gather your data, right? Why you think this is gonna happen, your observations, experiments, and then back to step one, hypothesize. If you got it right, if you kind of misled your experiment. There are also different factors depending on what experiment you want to do. Let's say your environment might have impacted your experiment. Yeah, just different factors. So just make sure you log all that down and keep that in mind. So that way you go back, trace back to your past steps and improve the experiment you made. But now here we have water, right? So I have my container just to prevent any spills from happening. I'm going to need some oil that I have here. So I want to, I don't want to use a lot of my oil, but and what I'm gonna do is I am going to, let's see, where is my food coloring? I should grab another container. Let me see this one. Let me grab another one really quick from our CMOT. Just grabbing another container here. And then we're going to add food coloring. And then at the end, we're going to add some Alka-Seltzer. Sorry, not Alka-Seltzer, and aspirin. So here, let's just put about half of our oil. That's a little too much. Here, like this. And let's just go ahead and add, let's say some food coloring. let's just add it to our water. Why not? Let's just do green. I don't know, but seeing that is very satisfying. So if I just put a droplet here and just watch it all, just, you know. Okay, so now I'm going to grab my spoon and mix it all up. Now we have green water, which will, you know, be easier for our experiment. So now I'm going to go ahead and add it to my solution. Actually, you know what? I should step back first for a while and exchange this one for this one. We'll use this water later, but I just remembered that it would be a cooler effect if I add my food coloring to my oil instead of using my water, and you'll see why in a second. But I'm going to, let's do green. Or maybe let's do green. We're gonna add it to our oil, which is here. This one, and we're gonna add a few droplets as to our oil, right? We're going to mix it up. So let me grab the spoon that I used earlier. Here it is. And let me just wipe my hands because I don't want anything to slip. So yeah. So again, we're gonna just stir it all up. Quick. You can see how all the little droplets of food coloring are dissipating. So again, you can tell how dense oil is, right? The little molecules inside here are starting to be their own individual here. So we're just gonna stir. Let me put that in the center. Just stir. Okay, let me just use this now, because that's faster. So we're just gonna stir. And keep stirring until you see like until everything should be like one color. So there we go. Oops, it's spilling a little bit. So let's step back. There we go. Alright, I'm going to put this there. Clean my hands really quick again. Oil is very messy. And just clean it up here. And then I'm going to add my food coloring here. And then very quickly it's going to come up to the top, right? However, if I add my aqua seltzer, let's see what happens. So let me just raise it up to the top and you can see my aqua seltzer. So let me just roll it around. And there we go. You can see that. Maybe if I stir it, you will see a cooler effect. So yeah. Thank you guys for following. Okay. There we go. Okay, I was expecting like, yeah. Okay, and there we go. We have that. So now we're actually going to move on to our project for the day. So the examples that I just showed you demonstrated, like, how different properties and have different densities because of their mass and volume. And oh my gosh, it's really hot today. It's a very hot day. But yeah. Okay. And yeah, just to recap, since we are midway through, today we were just talking about like different densities. So what is density? It is the measure of mass in the composition of a substance. So everything has mass and everything has, a different type of density. And we will, visually see that today in our project. So what you will need is like any container that you don't mind dirtying or, are not reusing later, because this can get pretty messy since we are dealing with oil, and any like household materials. So we have a container here. We have some ping pong balls just to demonstrate how, after we have our stackable, fluids, we can layers too, see how different objects react or sink or float through our jar. We have some food coloring too. Here, food coloring. We have, I have like this. It's not a syringe, more like just to push food out and food in. Which I can't. Oh, because it has a lid, right? We have this just to, add food and, just make it less messier for our liquids to transfer. We are dealing with first soap. We are dealing with oil as well, and we are dealing with milk. And also, I forgot, but we are using syrup, which I can dump into another container as well. Just so it's easier for me to, suck in everything. So just put in some syrup. There we go. That smells really nice. But yeah, here we go. So first we're gonna add, out of these, we're going to order them from here. So first we're gonna add our syrup. Then we're gonna add our detergent and our oil. Our milk and our oil. Can you scroll down a little bit? And then we also forgot about water. So here we have 5 right there. And then we have our water. And then for our water, we are gonna add some food coloring to it. Let's see, we have like brown, blue, white. Let me add, not blue. Let's do green again. We're missing some green in here. Okay, we're gonna add a few droplets. Let me show you guys up close how it looks. Just 1, 2, and 3. That was probably a little too much, but that's okay. And now I just need my spoon. Where did I leave my spoon? It's right here. I need to wipe this. So I don't want my water to fuse with the oil. Make sure. Okay. And we're just gonna stir it up. Alright, so again, here I have my syrup, which would be my bottom layer. And then I'm going to top that off with a layer. Okay, so we're gonna add our drinking bracer to the bottom, and now we're gonna add a milk. Actually, I had these flipped. So next thing would be milk, then our dish soap, and then the final layer will be oil, and then water. So there we have it. Just makes it easier for me to layer. But first, let's see if I can add in the honey here. So that's my first layer here. I'm not sure if you can tell. That's our first layer. Okay, I think that's good. Put that to the side and let all the honey come down to the middle, to the bottom. Sorry. Let me just clean this. So it doesn't mess up with our other. Let me add this here. Okay. There we have. Again, using honey or syrup and oil are very messy. So, you know, let me use this container here. So it doesn't stain our wooden boards. But yeah. Okay. And like coming back to this, I just saw it. But you can tell now that the oil is at the top and then the rest should be water. That's just like a cool, you know, after we let it sit for like a few minutes, we see how separated water and oil are. Which is very cool. And then, okay, so after I have my honey and it's all settled at the bottom, we are going to add a layer of milk. So now this is where I get my, I don't know, you're like a turkey baster, you could say. Not a turkey, but yeah, I guess you can say a turkey baster. But just something to suck in a good amount of milk. So there we go. Okay, so I think that should be enough. Ah! Okay. Here I got a little too much. Alright, so now in this process here, you don't want to forcefully, you know, just push down on it. You want to gently layer it at the bottom. So just, you know, just small droplets at a time. So if you can tell, it is not sinking to the bottom or mixing with the honey. Alright, let me just stop. And there you go. Because if you do press a little too hard, the milk will mix in with the honey, and we don't want that. We want to visually see the different layers and the different densities of that these all like fluids have. And I'm gonna just finish it off like that. And I think that's a good amount. Alright, so now I'm going to put this back in here. Alright, and let me just clean it off with some water. Okay, let me add some water just to clean it out. So I just want to clean out all of the milk that was in there, and let me just place it in here. Okay, so next thing we're going to do is add dish soap. So again, we're going to repeat the same process. We are going to add some soap to here. Ooh, that's going to be very funny. Okay. So we're adding soap. So again, I'm gently just pushing through. Pulling it, actually. Oh no, we are getting a little bit of a few air bubbles, but that's okay. Again, do not, just be very gentle with it, and let's just hope so that we can tell. Be very, very gentle. I am making like tiny circles so it doesn't break the surface tension and keeps, you know, the milk separate from the dish soap. And it seems to be working rather than just leaving it in one place, because that will create some tension and break that layer that it created. So once I have that and my circle is filled up, I can just add the rest of the dish soap. And they're here. Let me show you guys just a close-up of how the different layers are looking. And there we go. Just slowly going through it. Okay, this is looking very cool. Alright, nice. So now we have our first 3 layers here. That looks very cool. Okay, now I'm going to clean this up and then add my water next to it. However, I might have a little bit of soap stuck in here. So let me just clean it out. Give it, a whirl so that it comes out. And clean it one more time. Alright, that seems to look good. Did you get your mask? No? Okay, there. So now I think we got rid of the majority of the soap. Now the next layer would be on top of the dish soap. We're gonna add water. So like we did, we added food coloring. So this is our water. Just to differentiate the different layers, of course. And I am going to add here my water. Alright. Let me make sure. Okay. Again, very gently doing circles. And you can see how it's starting to create that layer. Different from the dishwater, the dish soap. Okay, now we're starting to create that layer here. Alright, I'm sorry, I'm like kind of concentrating because I don't want all the foods to fuse with each other. But yeah, basically what we are seeing here is how we see honey it's very thick, as you can tell and you've seen. It's very thick, right? So that's why we started that with our layer, because we know that it won't mix with the as high we go, our different densities are changing. So that's why we layered it with honey first. There we go. I think that's enough. Okay, that's enough of water. And then lastly we are left with oil. But since I want to keep stacking, I'm going to try to do my oil just without the syringe, because I don't want it to, be smothered with oil. So here I'm just slowly dripping it to the top. Oh, you can see how it's like bouncing back. So here's what I'm gonna do. I think that's as fine as of a layer we're gonna go, but yeah. You can see the dishwater is kind of mixing in with, that looks very nasty, with the milk. But then again, I'm going to add some honey. I want to create different layers. And let's see how that works. So here, gently again. Okay, that was very cool. Adding honey to it. Very gently. Okay, maybe not. Because we see how the honey is going through the other layers. But I was trying to stack up, create another stack of the same substances that I use, but we can tell that the honey is too thick. It's just gonna go right through all the rest of it. But yeah, okay, I should have gone. And let me just top it off with oil. Might as well. But there you go. I think that's fine. Okay, so we finished it. Our layer. It looks very cool. Again, like a substitution for dishwater, you can use like, I don't know, like laundry detergent too, because that is also has like a very thick consistency. So we layered it first with our maple syrup, right? It's just syrup, and then adding milk, whole milk, adding some dish soap. We topped it off with the next layer is water. You know, just added a little bit of food color to make it look a bit artsy and more, you know, pleasable. And then we just finished it off with some oil. But now I want to go ahead and try to see how, if I add a ping pong to it, if it will sink or float. What do you guys think? You guys want to just comment really quickly? If I add a ping pong down here, do you think the ping pong will float or sink? Remember we talked about the different densities and how if you have a smaller mass, things tend to float. And if you have a larger value, things tend to sink. Right? Yeah. Yeah, things tend to sink. Like I used the example before was, what did I use? Oh, the trick question was, what's heavier, 1 pound of feathers or 1 pound of bricks? And the short answer is neither. They both weigh the same. I know when I was asked this question, I was like, well, a pound of bricks is heavier, right? But actually, no, I was wrong because they gave me their explanation. I was just like, so now I understand. You know, just the foundation of density, because 1 pound, if you're asking for 1 pound of feathers and you're asking for 1 pound of bricks, you're just gonna get 1 pound. Nothing less, nothing more, you know? So whatever fills up a whole bag, an entire 1 pound bag of feathers, that's how much it's gonna weigh. And then if you give me, like, let's say 2-3 stacks of bricks, then that's just 1 pound. So yeah, that's pretty much the same thing. However, the feathers do take up more space because it is, you know, they're very thin and they require so much. I would say like a good like pallet or big bag of feathers to fill up to make a pound. But I digress. Let's try it out with the ping pong. Oh my gosh, I'm so scared. Let me look for my spoon first so I can scoop it out. Alright, so I think it's gonna float because of the oil, but we'll just have to see. And it floats. I was gonna say it's starting to sink in, but no. The oil has a very thick density, and oil itself is very thick. So as we saw earlier too, the bottom layer or beneath oil is water. But yeah, if I had placed it in water, like for example, this is my green water, and I had my ping pong, oops, it would float too. Because the mass of my ping pong is very, you know, it doesn't weigh too much. It's very low compared to the mass of water. But yeah. And then let me scoop this out and let's try with like a few other objects. Let me just skip that. Put it there. And then we're gonna add, let's say, a potato. Because potatoes, you know, we have it, why not? So do you guys think the potato will float or sink? DIY kids said afloat. You think the potato's gonna float? Or we're gonna go ahead and try it out. So I have a potato, and then 3, 2, 1, we're gonna drop it. And it floats. So if you can tell here, oh, it's starting. Yeah, you can tell here that our potato stopped. So it went through all the layers, all our 4 layers of milk, dish soap, water, and oil, and it stopped at the syrup one. Because syrup, again, has a very thick density. So I wonder what will get through the syrup to make it sink. Maybe something heavy, like... Okay, maybe not here. But I think that would be very cool to watch. Maybe a block of wood. But that's too much. Alright, but yeah. Anyways, this is our experiment. How the time? 8 minutes. So we have 8 minutes left. I want to retry this experiment that I tried here. It wasn't too successful. But let's see. If I want to take out the oil in that, and I don't have much oil, it's not gonna work. Let me see if I can add the oil to this. Add the few oil that I have in this container, and I have one last piece of what's this called? Aspirin. And then we're gonna drop it in. Okay, maybe that didn't work either. We can hear the sound, so that sound is just satisfying itself. So what was supposed to happen is the oil was supposed to fuse in with maybe I might put it at the top. Oh wow. But yeah, we see that reaction, and then you see what is happening, the layers here. What if I stir it around? Okay, so now the aspirin and the oil mixed in together. So what that says is that they like may have the same mass inside. But just to recap, in our last few minutes, we have 6 minutes left. The project we worked on today, it's called Density Pillar, and you can find that in our playbook. And like we just did here, this is an example, the outcome of it. Like I said, I was gonna stack more, but the syrup just went through it. Let me clean my hands. But yeah, today we just focused on the different, like how we have these household items, household fluids. We have the syrup, we have our milk, dish soap, water. What else did we add? I think that was everything. But and oil. So we're just missing our oil here. But yeah, you can easily find this like in your kitchen cabinets. Create this project here. Create other stacks. And yeah, like I know you can use oil and water to make like your own like DIY lava lamp. It's not gonna be, you know, there forever, but you know, it's just a cool experiment to just try out. But yeah, again, be very careful with using detergent and the oil because it does get pretty messy and sticky, like my hands are right now. But yeah, in our last 5 minutes, are those any tips for Baby powder works. Really? Baby powder and dish soap work to remove oil. I did not know that. Okay, next. I don't think I have any oil stains on my shirt. Thankfully, no, I don't. But I will try that next time because, yeah, it ruined my shirt. But anyways, I digress again. Yeah, all you have to need for this, if you don't, for this project, if you don't have it, is just to buy like these little packets, a food coloring that you can find like at any store, pretty much, like the 99-cent store or like your local grocery supermarket, just to make it look more a bit artsy, you know, instead of having just plain clear water. But yeah, this was our project for today, and hopefully we will see you guys next week. So you join me and an exciting project that we will do. Yeah. Thank you again for tuning in. And how much time? 4 minutes. Okay, let's see any last things I would want to recap from it. We started with our saltwater experiment with tap water. If I can still do that actually, just to show you guys. We have our egg here that will cause it to float. So we have here, and then we have our, ooh, this one is stained, huh? Let me try to clean this up. When can you get these, what? Is it safe to use? Is this safe for kids? I'd say it is safe for kids. This is safe for kids. I would, like I said, I just, hope parents supervise their kids because they are using oil. Well, like again, oil is very hard to, at least for me that I've tried, it's very hard for me to, remove from my clothes. And also detergent, which I know, kids like to touch things and, play around a lot, pretty much. But yeah, I would recommend this project for, let's say, like elementary to middle school. Yeah, because they're just like beginning to learn about science and how, just the basics of science, like the scientific method as well too. Like I mentioned before we started this, we like hypothesized what will sink, what would float. Oh, and yeah. So again, I have my 2 buckets, and then I have that one, and then you can tell from the overhead view. I don't want to spill it, but from the overhead view, you can tell like one. With the one with salt water, you can see the shell of the egg, which means that it's pretty much floating. Although from the sides, you can't really tell, but it is floating. And let me see. Also, you can tell it's staying upright rather than this one. It is just like kind of to the side and like tilted on its side, and it's not floating because we don't see the outer shell of the egg. So yeah. You can try this with anything, pretty much anything. Like I mentioned before, you can try this with oranges. Have an orange fully peeled, and then the other one like not peeled at all. My son is over there, and I want to make sure it is safe for him. Yes, it is. It is safe for him again. DIY mom, like if the parent is 10 minutes. If you're the parent, then I would recommend you to be very, very careful with handling oil. If you want to do that part, you can also do that part. But yeah, also using a syringe, or not a syringe, but like a turkey baster is helpful. But then again, thank you for tuning in, and we will see you next week.